Good morning, students. In the previous class, we discussed about the types of non-ideal solutions. Non-ideal solution which shows the positive deviation from the Rolle's law, and non-ideal solution showing the negative deviation from the Rolle's law. These two we are discussed in the previous class. In this class, we are going to be discussing about the azeotrope mixture. That is a azeotropic mixture. Mixture. This is very important. So many times asked in the examination. What is meant by azeotropic mixture? What is meant by azeotrope? That is, azeotropes are mixture of liquids. Azeotropes are the mixture of liquids. ಅದು ಏನು ಸ್ಪೆಷಲ್ ಪ್ರಾಪರ್ಟಿ ಇರುತ್ತೆ ವಿಚ್ ಶೋಸ್ ಏನಾಗಿರುತ್ತೆ ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ ಇರುತ್ತೆ ಯಾವುದರಲ್ಲಿ ಲಿಕ್ವಿಡ್ ಫೇಸಲ್ಲಿ ಮತ್ತು ವೇಪರ್ ಫೇಸಲ್ಲಿ ಕೂಡ ಅದನ್ನು ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ ಇರುತ್ತೆ ಅಂಥದ್ದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದರೆ ಅಜಿಯೋಟ್ರೋಪ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಅಜಿಯೋಟ್ರೋಪ್ಸ್ ಆರ್ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಲಿಕ್ವಿಡ್ಸ್ ವಿಚ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ದ ಸೇಮ್ ಕಾಂಪೋಸಿಷನ್ ಇನ್ ಲಿಕ್ವಿಡ್ ಅಂಡ್ ದಿ ವೇಪರ್ ಫೇಸ್. Liquid and the vapor phase when it boils at constant temperature. Boil at constant temperature. These we called as azeotropes. Azeotropes and the same composition irutte. Yavadalli liquid phase alli matte vapor phase alli kuda same composition irutte. But at constant temperature alli now boil madadaga. Then these components of this mixture, that is the components of the azeotropic mixture, that we cannot be separated by the fractional distillation. Fractional distillation use ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ನಾವು ಇದರಲ್ಲಿರುವಂಥ ಕಾಂಪೋನೆಂಟ್ಸ್ನ ನಾವು ಸಪ್ರೇಟ್ ಮಾಡೋಕ್ಕಲ್ಲ. we cannot be separated. There are two types of azeotropes. There are two types of azeotropes. Two types of azeotropes. The first one is there is solutions show that is large positive deviation from Rolle's law. From minimum boiling of azeotrope. First one is solutions show large positive deviation from Rolle's law from minimum boiling of the azeotrope. That is the first type of azeotrope. Example for this is mixture of ethanol. That is a mixture of ethanol and water. Mixture of ethanol and water. This shows that is a large positive deviation from minimum boiling of the azeotrope. That is nearly 78.1 degrees Celsius. At that temperature, at that boiling, this shows the large positive deviation from the Rolle's law. Then the second type means the solutions show large negative deviation. That is a negative deviation from Rolle's law. From maximum, it is the maximum boiling of azeotrope. There is an example for this type of azeotrope, that is mixture of nitric acid. That is the mixture of nitric acid and water. Here there are two types of azeotropes. One is the solution shows the large positive deviation from minimum boiling of the azeotrope. There is an example for that is mixture of that is ethanol and the water. Means at the 78.1 degree Celsius, which shows the large positive deviation. Then the next one is solutions which show that is a large negative deviation. Large negative deviation from the Rhodes law from maximum boiling of the azeotrope at a specific composition. We can say that a specific composition. That is the mixture of the nitric. Is example for this second type is the mixture of nitric acid and water. This is about the azeotropes. Azeotropes andre ಏನು ಅಂತ? Azeotropes is a mixture of liquids which are having the same composition at the liquid and the vapor phase at constant boiling, at constant temperature. That is a constant boiling that we called as azeotrope. There are two types. One shows the large positive deviation, minimum boiling, then large negative deviation for the maximum boiling. These are the two types of azeotropes. The next we are going to be discussing about the colligative properties. When it comes to that colligative properties, we will discuss the next topic, that is the colligative properties. That is colligative properties. Means the many properties of the solutions, tumbane properties of solutions which are responsible for the decrease of the vapor pressure. Tumba properties ಏನಾಗಿರುತ್ತೆ solutions ಅದು responsible ಆಗಿರುತ್ತೆ ಏನಕ್ಕೆ vapor pressure decrease ಆಗಕ್ಕೆ. Vapor pressure of the solution is going to be decreased. These properties we called as a colligative properties. These properties we called as a colligative properties. In this colligative properties, that is this colligative, this word is going to be derived from the Latin. Is going to be derived from the Latin. Yeah, the co means is nothing but co means together. Together. Co means together. Ligere means binds. Binds means the colligative. This word is derived from the Latin. The co means that is together. Here means binds. Means these properties are interdependent. These properties, the colligative properties are interdependent. One we know means other we can be calculated. Other we can be calculated. Then, if suppose in the exam they ask what are colligative properties. Here, the property of dilute solutions, the property of dilute solutions, which depends on the number of solute particles in a given volume of solvent, but not on the nature of the solute. This we call as a colligative property. ಯಾವ್ದನ್ನ ನಾವು colligative property ಅಂತ ಕರಿತೀವಿ? ಯಾವ್ದನ್ನ ಕರಿತೀವಿ ಅಂದ್ರೆ that is solution, that is the property of a dilute solution. Dilute solution ಆಗಿರಬೇಕು. ಆ ಪ್ರಾಪರ್ಟಿ ಏನಾಗಿರಬೇಕು? ನಂಬರ್ ಆಫ್ ಪಾರ್ಟಿಕಲ್ಸ್, ದಟ್ ಈಸ್ ನಂಬರ್ ಆಫ್ ಸಾಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಬೇಕು ಇನ್ ಎ ಗಿವನ್ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಸಾಲ್ವೆಂಟ್. ನಂಬರ್ ಆಫ್ ಸಾಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಬೇಕು, ಬಟ್ ನಾಟ್ ಆನ್ ದಿ ನೇಚರ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರಬಾರದು. ಅಂತ ಪ್ರಾಪರ್ಟಿನ ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂದರೆ colligative property. The property of a dilute solution which depends on the number of solute particles in a given volume of the solvent. But it does not depend on the nature of the solute. That we call as a colligative property. In your syllabus, we are going to be discussing 4 main important colligative properties. We are going to be discussing the 4 important colligative properties are the first one. The first one we are going to be taken as relative lowering of vapor pressure. Relative lowering of vapor pressure of solvent. This is the first qualitative property we are going to be discussing in our syllabus. The second one is elevation of boiling point. Elevation of boiling point of solvent. Elevation in boiling point of solvent. The third one is depression. That is a depression of freezing point of solvent. Depression in freezing point of solvent. Then the fourth one is osmotic pressure of solution. Osmotic pressure of solution. These four properties we are going to be discussing in your syllabus. These are very important for the examination purpose. Exam ke ತುಂಬಾನೇ important qualitative properties. ಇದರ ಮೇಲೆ 5 marks ಕ್ವೆಶ್ಚನ್ ಅಂತ ಇರುತ್ತೆ. ಆ 5 marks ಅಲ್ಲಿ ಕೂಡ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ಒಂದು 4 marks ಪ್ರಾಬ್ಲಮ್ ಇರುತ್ತೆ. ಇನ್ನು 1 marks ಗೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಡೆಫಿನೇಷನ್ ಕೇಳ್ತಾ ಹೋಗ್ತಾರೆ. These are very important in the solutions. That is now the 4 important qualitative properties are the relative lowering of vapor pressure of the solvent, then elevation, that is the elevation of boiling point of solvent, depression and freezing point of the solvent, and osmotic pressure of the solution. These are the 4 important qualitative properties. First, before going to the first qualitative property, that is relative lowering of vapor pressure of the solvent, that what is meant by lowering of vapor pressure of the solvent? We'll discuss that. That is the lowering of the vapor pressure of the solvent. Just let us consider. It is observed that we know that when the non-volatile solute is added to the volatile solvent, it's going to be volatile solvent. The vapor pressure of the solvent is going to be lowered. Why? Why is going to be lowered? Because if suppose non-volatile solute non-volatile solute volatile solvent ಗೆ add ಮಾಡಿ. Non-volatile, this is a volatile solvent. For the volatile solvent, non-volatile solute is going to be added. Non-volatile, whatever I mentioned in the dot, that we call as a solute particle. Just think it as a solute particles. Solute particles in the solvent. This together we call as a solution. That is solvent together we call as a solution. Means before adding the solute, the vapor pressure of the solvent is more because it is a volatile solvent. Volatile solvent means the escaping of these particles from the solvent is more. Therefore, the vapor pressure is more. After adding the non-volatile solute to the volatile solvent, at that time some of these surface of this solution is occupied by the solute particles. Yenagutte a surface of the solution mele some of the space is going to be occupied by the non-volatile solute particles. So occupy agutte avaga it's going to be avoiding the escaping of the that is solvent particles. At that time the vapor pressure of the solution is going to be decreases when compared to the vapor pressure of the pure solvent. The vapor pressure of the pure solvent we are going to be taken as vapor pressure of pure solvent is going to be taken as P1 naught. Then vapor pressure of solution is P1. At that time the lowering of vapor pressure we can be taken as lowering of vapor pressure is equal to, that is which is a mole, that is solvent is mole, that is the vapor pressure of the, that is mole, that is P1 or minus P1, that is P1 or minus P1, that is the vapor pressure of the pure solvent is going to be, the P1 is vapor pressure of the solution, means the difference of these two we called as a lowering of vapor pressure. The difference of these two we called as a lowering of vapor pressure. The next class will discuss about the first colligative property, that about the relative lowering of the vapor pressure. Before going to that, one thing I explained, what is meant by lowering of vapor pressure. Lowering of vapor pressure is nothing, it is ಏನು ಮಾಡ್ತೀವಿ, ಒಂದು ಇದರಲ್ಲಿ ಒಂದು ಬೀಕರಲ್ಲಿ ಏನು ಮಾಡ್ತೀವಿ, ವಾಲಟೈಲ್ ಸಾಲ್ವೆಂಟ್ ತಗೊಂಡಿವಿ, ಫಸ್ಟ್ ಅದರ ವೇಪರ್ ಪ್ರೆಷರ್ ನೋಡ್ತೀವಿ. ಆ ವೇಪರ್ ಪ್ರೆಷರ್ ಏನಾಗಿರುತ್ತೆ, ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಯಾಕೆಂದರೆ ಅದು ವಾಲಟೈಲ್ ಆಲ್ರೆಡಿ ಎಸ್ಕೇಪಿಂಗ್ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀವಿ. ಯಾವಾಗ ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ನ ಆ್ಯಡ್ ಮಾಡ್ತೀವೋ ಆವಾಗ ಏನಾಗುತ್ತೆ, ಸರ್ಫೇಸ್ ಆಫ್ ದ ಸೊಲ್ಯೂಷನ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ occupied by these solute particles. Some of the surface of the solution is going to be, ಅಂದರೆ ಪೂರ್ತಿ ಅಲ್ಲದಿದ್ದು ಸ್ವಲ್ಪ ಸರ್ಫೇಸ್ ಏನಾಗುತ್ತೆ, ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಇಂದ ಆಕ್ಯುಪೈ ಆಗುತ್ತೆ. ಆವಾಗ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಎಸ್ಕೇಪಿಂಗ್ ಆಫ್ ದೀಸ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಫ್ರಮ್ ದ ಲಿಕ್ವಿಡ್ is going to be decreases. At that time the vapor pressure is also be decreases. This we call as a lowering of vapor pressure.